building cloud-based production system on AWS. We call it PAM or Production Asset Management. My name is Mahmoud Khatib. I'm Cloud Architect and Product Manager in Broadcast Solution Group. Is a media and broadcast company. We have office in MENA and the Middle East. I have multiple certification from AWS. And this session will focus on how to build a production asset management system on AWS using AWS services, because you can build it using on-prem, using on-prem infrastructure, but also you can build it using AWS native services only. This session is mainly will focus on media and broadcast domain. Is different domain. So maybe you know that AWS, they have media services, but today I will not speak about media services in AWS. I will speak about another services to build a PAM system. This PowerPoint session is collection of articles I wrote over the last 2 years, and I have all references in this PowerPoint, and also you can find all information and implementation configuration in the articles. And here in this PowerPoint will be summary about this collection of articles. So first I will start with explaining what is the PAM service for those who don't know what this PAM means in media and broadcast domain. Then I will explain the building blocks for the system or infrastructure. And number 3 will be about workflows. So after you build the infrastructure, you need to configure and build the workflows. Then 4, I will explain about one real example for the existing infrastructure or platform. And number 5, the future or the concept for the PAM system. So first here, let me explain what PAM means. Before you know what PAM means, you have different systems under one umbrella. They call it asset management umbrella. You have PAM, MAM, and DAM. In most cases, if you have one system, will be combination of PAM and MAM system. So MAM is media asset management and PAM is production asset management. So this here I'll explain the main topics, but there's more details. But here the main topics. When you have for some organization maybe they have only one system, either PAM or MAM. If this is bigger organization, they will have all systems together, and they work together in one workflow. So in PAM system, you will ingest through media, you will start editing, you will have collection of services, and you will have online storage, main storage, where you will ingest all your media, like for video, for audio, pictures, all media assets will be ingested in the MAM service and the online storage. In MAM system, you can edit here, or you can edit in PAM system or MAM system. But the main point, after you ingest the media assets, you will start editing, you will add watermark, you will create clips, you will add graphics. So all this will happen after the ingest. And DAM system, you only will send the finished assets or what you need to store for later. So if you have World Cup, since last World Cup, first you will ingest the online storage, and you will publish social media, will do whatever you want. Then after first World Cup is finished, you will send to the other system. So mainly will be from online storage. Then you will send to linear storage, and then you archive it in the DAM system or the cold storage. Then you can develop your workflow, archive and retrieval on-prem or AWS. AWS, you will use lifecycle management using S3 lifecycle management. So for example, if you have World Cup, after World Cup will finish, you will send to the DAM system. Here you send all finished assets. Now this year we have another World Cup, so you need to create a new media, a new news. So you need to retrieve from the DAM system. Here you can search after you have everything finished. You can search. I want to search about specific player, specific coach, specific match. You can search here, then you can retrieve. So this is mainly the only the main points about what the systems or asset management umbrella means. We focus on BAM system. For some platforms, you can call it map system also, but DAM system is different. Here I have picture example for the DAM system, digital media asset management. Here you will send only the finished assets. Then here you will start searching based on the metadata that you insert before. So why we need to move to AWS? Because here you can use it as an on-prem solution, or you can build it using AWS or cloud services. Because if you need to build on-prem, it will be expensive for infrastructure. You need to have a storage. You need to have different physical servers, and also you need to keep upgrading the system. So this we have a scalability issue. Also, it's difficult for remote collaboration because if you need to have editor, they work online or in different countries, you need to configure all the policies on your firewall, and you need to manage all the VPNs, user to side, point to side. So this would be much difficult. And also for DR, if you need to build DR, you need to build same or copy paste the same infrastructure to the another building or another different city. So this the challenges here. So if we need to explain the BAM system using AWS components or building blocks, you have more layers, but here the main layers that you need in any BAM system. You need authorization and authentication layers for users for manage policy permissions. You need ingest layers. Ingest layers mean you need to how you will ingest or upload the media to the system. And also for storage, you have different kinds of storage. We will see later. You have temporary storage, local storage, you have online storage, nearline, or hot and cold storage. Also, we need compute or workstations and servers, and also we need editing workstation for editors who will work on the assets after you ingest in the system. And you also have asset management and metadata layers. This here, after you ingest all media, if you have one video, you need to add metadata. You need to explain what this asset has or this video. If you have football match, you need to explain this between which teams and which players are playing and what the score. And you have many in which country, in which stadium. So you have different metadata you need to insert. So when you archive it, it's easy to search about this asset. And also you need observation, you need monitoring for the system. And last one for security, how to secure your system. If we can start here, I have this drawing, this for the basic on-prem or traditional authentication organization. If you have usually what you will have on-prem, you will have Active Directory, you have domain controller, and you will have shared storage. And this will be added to the domain. And you have here workstation or user. So each user you will access his own workstation and will write username, password, and authenticate using the traditional protocols to the Active Directory. And then based on his permission, either he can access to the shared storage or he can access only to specific folders. So this how it works using traditional system or on-prem system. You have Windows Server, you add all services, Active Directory, FTP, and permissions, and then user will access using their machine and then authenticate and start working. If we need to convert this using AWS services, you will have Active Directory, manage Active Directory. You will need to use storage nodes. Here you can use if you need Windows or Linux, but mainly you will use in the system will be Windows machine. So here you will use FSX for the services as a shared storage. And here you have two options for the users. So either you can use EC2 and you have local storage AWS, or you can use workspaces as a managed service. So here you on this side you will have the workstations or the PCs that user will access, and then you authenticate to the Active Directory. Then they will access the shared storage. So this the system, same system here, but here using AWS native services. Of course, you will have the same protocols when you want to authenticate to Active Directory when you for permissions, because in AWS also you will use Windows Server and Active Directory. But here is a drawing for AWS infrastructure or account or native services. Ingest, here ingest, I mean how you will ingest or insert or upload your assets. Asset, I mean video, audio, pictures, anything you will ingest to the system. In case we have in our use case, we have the system is built using AWS services. We have this here. This box is for ingest layer. The users, they will after they shoot the event, they will have a card or USB. So they need to ingest the system. If they using on in this case because we have AWS and they will be on-prem, they will upload or import to S3 using different like method. You either you will mount to S3 and upload, or in case as we will see in this PowerPoint, you have many platforms that provide this BAM system. So they will have their own GUI, and then you will upload to S3. And some cases you maybe have NAS storage. So this user will ingest first to NAS storage, and then you will sync to the main storage on AWS. So in this step, you will ingest your raw assets to the system, and will be in online storage in as a first stage. For shared storage, after you ingest all assets in first step, the BAM system will transcode the assets. You cannot work on the asset with the high resolution. You need to transcode the assets, and you will generate proxy and lower version from the asset, so you can work on it easier using Adobe or DaVinci. So you can edit the assets on the proxy. And first stage, you cannot edit direct on the S3. You need to edit on your local storage, on system local storage. So you will first edit on FSX because we are using Windows system. With transcode here, and then you will move to the online storage. So this commode is shared storage layer. For object, after you work and edit or create clips or add watermark or everything on the assets, you will send it on online storage. So in our case here, we have video assets will be in online storage in specific folders based on the software you are using. For compute, after you ingest and authenticate to the system and edit, you need to give permission to remove editors or local editors. They need to edit the assets or work on the asset. And they, in this case, they will use EC2 or workspaces based on the use case, and they will start editing the asset on the local storage. Of course, you will have specific database. Usually will be either MongoDB or RDS SQL database. Many platforms they are using SQL to store the metadata. So in each asset, you will have a proxy, you will have high res, and you will have metadata. So all of this linked together in case you want to search for metadata. For example, you want to search for Messi, so you are searching in database. Then, based on your search, you will have all entity or records or result in the system. So this will be stored in RDS. And of course, but best practice, you will have main and you will have a main and secondary, and you will have a backup every week. This is for metadata layer. This for monitoring. So what I saw from different platform and vendors, either you will use AWS native services, you will use CloudWatch for monitoring, and logins, you will use CloudWatch logs, and you will store all logs in S3 online. Then you can send it to inline storage or different tier. And for notification, you can use SNS and Event Bridge. So in this case, you are using only native services. And also another case, you can build your own monitoring system or observation using the open source tools. So what you will have EC2 instance with specific specs, and you will install Grafana and Prometheus on it. And you will configure everything to monitor your system that will be built on microservices or Docker Compose. And also you can monitor your software layer that built inside the EC2 instances. And you also can integrate with the CloudWatch to monitor the AWS account or infrastructure. And you can keep using S3 for logs, for store logs, and you can use notification SNS, or you can use Grafana and Lead Manager. So in this case here, we are using open source tools. In this case here, we're only using native services. This will be based on the vendor or your customer requirements. This example here, you can read all these articles with more details. This here, what I saw from different vendors. You will have your monitoring server, will be EC2 instance, and you will install Grafana and Prometheus as a Docker Compose, for example, here. And then all your targets here, all your system, like your system will be built over EC2 instances. Then you can configure Prometheus and Grafana to retrieve all the logs and metrics and monitor all your system using Grafana. And here on this articles, you will have more information how you configure and with everything. This security layers, how you can secure your infrastructure. So after you've built your infrastructure, you need to secure it. By default, you will have layer 3, layer 4. You will have access list, you will have security group. So your infrastructure will be secure, and you will have load balancer in front of your infrastructure, and all your services will be private. Your S2 instances, your S3, all will be private, and you only have load balancer, public load balancer to receive a request from different location and from users. You can keep it like this, and it will be secure, but you only protect your infrastructure using layer 3, layer 4. But you have different kind of attacks. So for advanced configuration, you need to use edge services, because here you have load balancer, you have security group for load balancer, you have access list, you have security group. This is regional, on region level. But for what more advanced and to support the layer 7, you need to use edge services. It's like a Shield, and you have CDN or CloudFront, you have WAF, and you have Route 53. We'll see after this more details, but the main point here, by default, you will have layer 3, layer 4 regional services or protection, and here you will be more secure to support layer 7, like Shield and CDN and WAF services. Here I will speak about workflows. So after we saw the components or building blocks for the infrastructure, we need to build the workflows or configure the workflow. First workflow is authentication. Same what I explained before, but here is more details. And here you can see in this article more details about how you configure and you build this infrastructure. So as explained, you have Active Directory, domain controller, you have local storage, FSX, and you have the workstation where the user need to access and start accessing the asset and start editing. So here, first, user will access the system, will use his username, password, then authenticate to the Active Directory, and will mount to the local storage and will start edit. Or they can use workspaces, same use case, but here is my services and EC2 instances you need to manage and you need to configure and add to the domain. Here more advanced authentication organization. Here in this, in case here same infrastructure we have, but here and you authenticate and use Active Directory, AWS Active Directory or domain controller. But sometimes you already have a Azure tenant and you have all accounts and email addresses on Azure, your Azure tenant, and you will have on-prem domain controller, and you have sync with your Azure tenant, and you don't need to create again users in Active Directory inside AWS. You need to use your existing emails on Azure. In this case, you need to configure the connectivity between AWS SSO and your Azure tenant, and then users, either if they are on-prem, you will use intra-registered, or they are in remote location, will be intra-joined. They can access the system using their own account on Azure instead of creating the email address again on AWS on Active Directory. And you will find more information and how to deploy this in this article, how you deploy the integration between AWS and Azure, and how you configure intra-registered and intra-join, and how you authenticate or configure the connection between Azure tenant and your on-prem domain controller. So either you will use the default or native solution, you will create all users on Active Directory on AWS, or you can have hybrid solution. You can create for the user here, and for your employee, you can integrate with your Azure tenant. This workflow is again for authentication. This for remote editing. After you authenticate, you need to access remotely. So as I explained before, but here this specific drawing only for remote editing. Here you can either use AWS EC2 instances or use workspace, and then you authenticate. Same what explained before, but here specific workflow for remote editing. And here more explanation. When you need to use remote editing in AWS, you have on-prem PC, and you have your EC2 instance, and you have different protocols you need to use to stream. So here you will not use RDP or SSH. You are using streaming protocols like PC over IP or DCV client. You install specific application or your machine to authenticate to Active Directory and access your machine. So we have here two drawing for remote editing. For security, if we consider this infrastructure is our building blocks BAM system. And here we have regional services, which is the load balancer, access list, security group. Until here is secure. Everyone can access the load balancer, but it's secure at layer 3, layer 4 only. To make it more secure and to prevent attacks before they came to your infrastructure or regional, you need to use AWS edge services to protect or to stop the attacks on the edge level instead of regional level. So in this case, you have by default Shield work on layer 4. This is standard. You can keep using standard, but it's working by default, or you can upgrade to use advanced Shield. And you need to configure remote Route 53 or DNS on AWS. Then you have services, then you have CloudFront. In this article here from AWS, they have more information. And here I have one scenario, which is if the end user they want to access your applications for a specific URL, first they will hit the DNS or Route 53. This layer 1 of defense. They will translate from URL to IP address. Then before hitting the answer, we'll go to CloudFront. CloudFront is linked with WAF services, and here you configure different access policies, and here we'll check. So we have second line of defense, and you have third line of defense to check that your request based on your access list. You have different access lists. For example, if you have for a specific country, so the request will be blocked here. They will not access to your load balancer. If you want to block different countries, you can do it also on CloudFront. So in this case, your request will be checked or denied or allowed here. And you can check the logs or send the logs to CloudWatch and store it in WAF. S3 only for WAF logs. This one of the solution use DNS CloudFront link with WAF rules. Then if the request is allowed, will be sent to load balancer. So if you here, you can see the difference. In this case here, when you are using edge services, you are covering all layers. Here you are supporting layer 7, and here you're only supporting layer 3 and 4. So here you prevent the attacks on edge location. And this also CloudFront is useful because when you are using cloud, you are using media or video and audio would be you need more traffic. So here you are working with edge location. So if you are working here in UAE and you have your infrastructure in Europe, and someone from Oman download one asset, will be stored on Oman or UAE edge location. So no need to every time you upload from S3 in Europe. So this will be also useful for security and for latency. This workflow was unique based on the customer requirements. In this case here, what I want, the customer, they want to upload assets to S3, okay, but they don't want to send the asset to on-premise storage before making sure that asset is secure. There's no virus, there's no security issue before sending to on-prem. So before last year, you used to configure your own antivirus on EC2. Then you configure your own workflow. So each time you uploading asset to S3, you need to trigger using the function and send the asset to S3 to check using licensed antivirus or third party. But since last year, AWS, they have a new service where you can enable guard duty on backed level on specific watch folder. So every time you upload a new asset on S3, AWS will check the asset and will make sure that asset is clean, is no issue with it before can continue. They will do this using guard duty, and then they will add specific metadata or tag on the asset if this is okay or is not okay. After that, you can send the asset to a specific, this I call it staging or DMZ, where I scan everything. If the asset is okay, I can send it to another S3, or I can send it direct to on-prem storage. So this was a unique workflow or request from the customer. And you can read here the full article and how you can configure this. Of course, here the service is limited, so you cannot scan more than 5 GB. This workflow I explained to you. If you have only BAM or MAM system, you will have only online storage. But after the event or after 1 year where the event is finished, you need to send it to nearline because you cannot expand your online storage every time. You need to start sending it to nearline storage or another tier from S3. So here you can configure your workflow using Lambda function, serverless workflow. So you can configure every 3 months. I need to send all assets from a specific folder to another S3. And then after 6 months, I need to send it to cold storage. So usually you configure this here using Lambda function. We have same scenario if you are using on-prem solution, but you will have different configuration based on the vendor that you are using. But if you want to use and you have AWS native services, you can configure lifecycle management and you can move assets using Lambda function. And in this article, you can read more about the use case and how you configure this workflow. This workflow also it's based on the customer requirement. In this case here, in case you have the BAM system built on AWS and you have online storage or another platform where you want to sync your on-prem storage with AWS S3, you can use third-party software or agent. But if you need to use AWS services, you can use DataSync. DataSync is mainly used for migration, but also you can use it as a sync service or agent. So in this case, I have two tasks. Why? Because the customer, they have two ways. They want to sync from on-prem to S3, and they want also to sync from S3 to on-prem, but for different folders. So here I created two tasks. One task will sync from on-prem to cloud, and other task number 2 will sync from cloud to on-prem. And here I'm using Lambda function and event bridge. Why? Because data sync, you can sync every 5 minutes, minimum every 5 minutes. But if I have use case, I need to sync less than 5 minutes, every 3, 4, or 2 minutes. I cannot do this in AWS data sync. I can't trigger data sync every less than 5 minutes. So I need another service to trigger data sync. In this case, I'm using event bridge as a trigger to trigger the Lambda function. That here in Lambda function, I will have a specific code that will ask Lambda data sync to start scanning the watch folder for example, every 2 minutes. So here I'm using event bridge and Lambda function to scan the watch folder in less than 5 minutes. Here is more details how I configure this. So for example, I need 5 minutes from on-prem to S3 and in 10 minutes from S3 to on-prem. Here only for example, but you can use 5, 10, and you can use less than 5. But here is only for example for article. Go on the customer, I configure less than 5 minutes, but here only to make it much easier. You configure 2 rules in event bridge. Rule number 1 from on-prem to cloud. You will trigger Lambda function that will scan or will run the data sync task 1 that will start sync the assets from on-prem to S3. And here is the steps that data sync will use. First, they will launch and prepare verification and this either the success or fail. That's why here I have CloudWatch is linked to Event Bridge, and also by default, data sync will send logs to specific S3. You create it, or you have it, or you get a new S3. So you can see the logs and which folders have been synced or skipped based on your configuration to the sync. And this rule number one, this rule number two, to sync from cloud to on-prem. This is more low-level explanation. So here in on-prem, I have a folder structure. In the cloud, I have same folder structure, but I am syncing two different locations. So here, if you check here, I have source and destination, and here source and destination. So sync task one will be from on-prem to cloud, and this will be from cloud to on-prem. And of course, the traffic will be encrypted. And here I'm syncing using normal NAS storage, using SNMP protocol. And you will use task ARN to configure the event bridge. And you configure your policy using task. And here I have also a link for this article for more information on how you configure and implement this use case. This also same topic, but more low level details. So I have here two rules, two jobs, two rules, and two Lambda functions. But you can use only one Lambda function. But here I'm using two Lambda functions, and I'm sending the logs, basic logs, and transfer logs to CloudWatch and etc. Here I have read example for one of the platforms. Like the name of this Dalet Flex platform. This is example for MAM and BAM system using microservices on AWS. So this infrastructure for Dataflex, and here you can read more about the documentation. But mainly you will have collection of EC2 instances that will host your application software layer, and you will have RDS for metadata, and you will have load balancer out of Route 53. And of course, you are deploying using 3 availability zones, and you are replicating the services. And you will have EFS, and you will have S3, and you have another tier from S3. So this is same what I explained before, but here using AWS infrastructure services, not boxes or building blocks. This is the main infrastructure for the BAM or MAP system. Here is low-level details about how this works. So here, if you imagine, I have here the MAM system. MAM system, usually what I need transcoders. So, and here I have S3, but I have here inbox and I have storage. So in same S3, I created different folders. So inbox here, when I user they upload assets from different locations, each one of them they have different assets. So they will will upload to specific watch folder. We call it, for example, inbox. And when you upload to inbox, you will have a specific code, will scan all assets and will transcode them and send them to another folder before you going to transcoder. And after transcoding, based on transcoding configuration, you will send to different folder. And here you will have proxy and you have transcoded assets. The member from this example that for my infrastructure, I'm using on-prem or on-demand or reverse instances that support only 2 instances. So I have only 2 transcoders. But if I have more users, more than 4 users, and all of them, they will need to upload every day, I will have issue at the end because I need more than 2 transcoders. I can add more, but if my users keep growing, I need to add more transcoders. And if I'm using on demand, I am paying more. So this first use case, you are using native solution, basic solution, using EC2 instances, on demand or reserve instances. And you need to, if you are growing, you need to scale. So to solve this, you can use AKS. So for AKS, I'm only using the transcoding function. So I will use AKS. I will have minimum and maximum number of transcoders. So in this case, if I have only 4, I need only 3 transcoders. If I have 10 users that are uploading at the same time, I will scale and scale up and scale down much easier. So some vendors they're using this use case using Kubernetes for transcoding. Uh, here I'm using full explanation. Uploading to S3, you have AKS instances, get a proxy, and you will have similar to this user interface. You have all assets here, and you can have your own workflow before publishing social media. So this here is specific use case. The last topic I want to speak about is the future of enterprise integration platforms, which here, what I mean here, if you have only one platform, so it's okay. There's no integration with many platforms. But if you have used many platforms or two or three platforms, they all integrate to each other. We need to configure each platform. Uh, uh, like you need to go to each platform and configure it. You don't have one location to configure all your platforms. So now there's a new concept in media where if you have here, for example, here, if you have vendor 1, 2, 3, 4, and all of them they have open APIs, and you integrate all of them together, by default, you need to go to each vendor or each platform to configure the internal workflow. But what you can have, you can use controller or another control system where you can see all your platform in one location. And here you can use multi-vendor controller or specific application and to configure all platforms in one location instead of going to each platform and configure it. Here I only, for example, you can consider this as an MCP server and you are using algorithm or workflow or tool like in 8N. So imagine you have using same automation tool and you have all your platform as a boxes and you are configure all of them in one location and you are pushing the configuration to them using Thomas Mount interface. If you are aware of SDN or software defined network concept, you understand more. But here the main idea or the concept that you don't need to configure all your BAM or MAM system by one. No, you can follow the SDN concept or centralized location to configure your workflow and you push all configuration to your vendors because all of them, they have APIs. So this is what the last point is enterprise integration platform to manage many other platforms or BAM or MAM platforms. Here, last slide, you have all these articles where you can go by one and read more information about each component or each slide from my presentation. For more details, more information about how to implement, how you can configure. And thank you. This was the last slide.